Hey everyone, my name is Paul Ruiz, and I am a developer programs engineer on Firebase at Google. So today we're going to talk about two tools, Flutter and Firebase, and how they can be used for rapid prototyping. So whether it's at a hackathon with only 1 weekend to build something presentable, or you have an idea for an app that you really want to test out before investing in it, a lot of us have been in a situation where we want to build something that gets the job done quickly. So during the normal development prototyping process, developers will plan out what their app should do and how it should function, research the feasibility of the idea, map out their architecture, pick their tools, and then build a clean and organized prototype, right? So yes and no. Some people will stick to a very formal process, but when building out a quick prototype or a proof of concept app, most of us, myself included, just want to open up an IDE and start coding, and then we'll sort of figure it out as we go along. So given this, I'm going to talk about the two tools that I mentioned earlier, Flutter and Firebase. Both of these are easy to use and address different development problems. Flutter is for client-side development, and Firebase is for the backend. Both are designed to be easy to use, and they are both well supported with content and documentation to make getting up and running as easy as possible. So while I wouldn't necessarily say this is a deep dive, this presentation is going to look at some code and tools that'll hopefully be helpful in getting you started with Flutter and Firebase. So while it might seem like a lot up front, I can't stress enough that you don't need to memorize everything. So this is also a condensed version of the presentation, so everyone can definitely reach out to me if you need more information or links or what have you. Just kind of flesh out anything that you're actually interested in. So what I do hope to do with this talk, though, is help you leave with the vocabulary to look into both of these tools further when you're ready to use them. I'll also be posting the slides up on Twitter so that you can reference back through any of the code that's here. So you don't need to worry about writing everything down or really just focus on paying attention, essentially. So with that, let's just go ahead and get started. So first, let's talk about Flutter. It's a UI toolkit that uses the Dart programming language for building native apps for multiple platforms on top of C++ using a 2D engine called Skia, which is the same graphical engine that's used by Chrome, Android, and a few other platforms. And it's all from a single SDK. Since everything is built from a single code base, you can actually create your prototypes for multiple systems, such as Android or iOS, without requiring specific developer knowledge about each platform. Flutter is also completely open sourced. So not only is Google working on it, but so are many members of the developer community. So rather than being walled off from the internal workings of the tool, you can dig into the code to see exactly how Flutter is doing what it's doing, as well as send your own pull request if you want to improve it. So far there's been something like 18,000 contributions, all from the global developer community into Flutter. And that number just keeps rising as more people are discovering and trying out the platform. So aside from Flutter being cross-platform, you're probably wondering when you should use it for rapid prototyping, especially since other tools exist that do similar things. So like most development decisions, the answer is basically, it depends. While Flutter isn't the only tool that can work cross-platform, it is designed from the ground up specifically for creating apps quickly. It's able to easily tie into device hardware using external plugins and packages that can be imported into your project, and uses widgets, which we'll dig into a little bit more soon, to create UI components programmatically rather than requiring something like a layout file or a storyboard. One other feature of Flutter that I think is super valuable is hot reloading, so you don't need to restart your entire app to test small UI changes. Instead, UI changes will automatically be applied in your running app as you change various values. So following up on the it depends answer, there's also going to be times when Flutter isn't the right solution for you, and it's better to figure that out early in the development process. So for starters, games are a lot of fun to develop, but Flutter just isn't really at a point where you can make most types of games quick enough to call it a rapid prototype. You'll need to write a lot of components from scratch that other platforms currently give you out of the box. Additionally, calling native APIs directly just isn't super easy. Normally, you would write native Swift or Kotlin code, and then use platform channels to communicate back and forth to the native level through a bridging process. So while this isn't necessarily a deal breaker, it is more work than just throwing some UI together and then calling it good. The next thing to consider is audio support, or rather the lack thereof. While audio isn't supported by native widgets, there are third-party plugins out there that can provide this functionality. Which brings me to my next point. While there's a ton of plugins for Flutter, some third-party libraries that developers have grown to love just aren't really available right now. You'll have to weigh the necessity of things like that versus working with what Flutter has before deciding to use the tool. Fortunately, there's alternatives to most things, but we'll kind of dig into that more later. Finally, Flutter doesn't have support for additional form factors like watches, televisions, and cars. So right now, Flutter does kind of have very limited support for Wear OS, but absolutely no support for platforms like tvOS. And then, like we've talked about already, one of the biggest draws to Flutter for rapid prototyping is that it's an easy-to-use tool for creating custom UIs. The first part of this presentation is where this talk starts to get a bit more into the technical side of things, as I want to give an overview of some of the ways that Flutter can be used to build UIs. So when you're working with Flutter, everything is a widget, and all UI is described by widgets in a tree structure. So one key term that you'll see in Flutter documentation around this is aggressive composition, which essentially just means that aside from some very basic widgets, the widgets that you use in your app, either custom ones that you put together or that come built into a platform, will be made from other widgets. So you can think of them like bricks where you just kind of connect them together to build whatever you want. So while there are hundreds of widgets, I want to go over just kind of a few at a really high level to give you an idea of this fundamental part of Flutter. So as a lot of you know, you can't really start with anything in software without Hello World, right? So let's take a look at this example to get an idea of how Flutter uses widgets to create a bare bones user interface. All our apps use the main function as their entry point, and in there you can initialize various components and start your Flutter application. You can also see a center widget in this example, which will center your content into the middle of the device screen. Next up is the text widget that, as you can probably guess, is going to show some text. And this text widget also has a few properties that can be applied to it. So the first one is a string that will be displayed by the text widget. And the second is a named optional property, which in this case is text direction, that can be used to customize the widget. So all said and done, you'll end up with this stunning example of pretty much the most simple user interface you could ever find. But it's Hello World. So the next component that I want to talk about is the list, since honestly, most apps are essentially just list and detail screens. So there's actually a lot that you can do with list, like setting them up for infinite scrolling, having items react to long presses, adding various custom composite widgets, and some other things that you can do with it. So to keep everything simple for this example, we'll start by just looking at the code for a super basic list of generated text items with a circle icon. So the first widget here is the scroll bar. While it's not necessary, it does provide, as you can probably guess, a scroll bar on the side of a list so that users know how far along in the data they are. After that is the actual list view widget, which provides the scrollable area that contains and controls the list items. This widget also has a collection of properties that can be set to customize the list. So here you can see that we're setting a padding to the top and bottom of the list view, though the only required property is the children array, which will house the items that exist inside of this list. The next part is where this component gets a little bit more interesting. So while you can include a simple list or array data structure of other widgets, there's also this great list.generate call that can loop a set number of times to create widgets for your list view. So in this case, we're simply just going to create 100 items that will be displayed within our app. Each of those 100 items will be made up of a single list tile widget, which implements the material design spec for list items for you out of the box, and is generally used to display some text and a leading item like an icon for each list item. And as you might expect, this list tile has its own properties. So the first one is the exclude semantics widget, which wraps a circle avatar. This will display the index from the generated list as an icon at the start of the list item. And since it's wrapped by the exclude semantics widget, it won't be read by accessibility tools like screen readers, meaning it's not going to add noise for the users that do need to use those tools. One thing that's worth mentioning here too is that if you're going to use the exclude semantics widget, you need to use it very sparingly and only when there's a very clear and justifiable reason, because a lot of people do rely on these screen readers and other accessibility tools. So you want to make sure that you're providing the best experience for them as well as your other users. And then the final part of the list tile widget in our list view is probably the most simple. It's just going to be a single string and a text widget that represents the content of our list item. So this is actually the same kind of text widget that we just saw a minute ago in our Hello World app. So for the next few slides, I just want to introduce some of the widgets that I think are particularly useful for developers who are just starting with Flutter without getting in a lot of code just for the sake of time. So the first of these useful widgets is the card widget, which provides a card item that can be put into your list views. So these cards are also containers, so you can create completely custom UIs to put into them. So in this case, we have images and text and whatnot, but you could also put in GIFs or videos or anything else that you might want to use for your UI within these cards and still have that design pattern working with it. Next up is the TextField widget, which allows users to enter text into your app. So you can see here that there's a lot of ways that you can customize a text field, such as restricting it to numbers, hiding enter characters for passwords, or validating content based on values in other parts of your app. So finally, there's the Picker widget, which will let your users pick dates from a calendar or clock without having to recreate this common UI flow. So if you come from the Android world, this is usually something that you would import as a third-party library, but it just happens to be built into Flutter at this point. So far we've covered a very small handful of common widgets, but I haven't even broken the surface on how many are actually out there. So to learn more, I really recommend checking out the Google Developers YouTube channel to find the Widgets of the Week videos, and to check out the official widgets reference documentation at flutter.dev. And just as a side note here, I think there's roughly 80 videos in this Widget of the Week setup, and most of them are around a minute long. So it doesn't take too long to get through them, but I really recommend it if you're going to get into Flutter, just so you have an idea of what's out there and what you can use as well. So now that we've covered some common tools, I wanted to get into some stuff that's going to be a little bit more interesting and useful when it comes to learning the platform quickly and creating some prototypes. So the first tool that's great for getting up and running quickly is the Flutter Gallery app. This app is entirely open sourced and available on GitHub, meaning that you can grab whatever functionality that you like out of it to throw into your prototypes. It goes over a collection of widgets that you can use with both Material and Cupertino, which is the iOS styling. It has a lot of other useful features that you can mess around with in this Playground app. Each widget section in this Gallery app includes a descriptor and can bring up the code that was used to create that section. Each widget page also has an icon at the top that will take you directly to the official documentation for the widget that you're looking at. Additionally, there's a variety of tools that can show you how to do animations, media playback, or just display each of the available stock colors in Flutter to help you get your apps put together even faster. The Gallery app also includes case studies, so you can see how common features work together in a big picture scenario, rather than just kind of a bunch of one-off widgets. So in here, you can see a staggered grid view, hero animation, circular animations, different types in a single list, and a few other useful items in just the screenshots. So this is great when you're trying to put together a quick prototype, as you get examples of animations and interactive components out of the box, rather than just spending a bunch of your time trying to figure out how to work through solved problems from random blog posts online, Stack Overflow, or other documentation. But speaking of documentation, as you've probably noticed, I've already mentioned it a bit already. So I'm a huge fan of what the Flutter team has already put together, especially since a lot of it isn't just the standard, this component does something sort of stuff. So one of the things that they have is the Flutter Cookbook, which is the documentation page containing various code samples, or recipes, which is where the name comes from, for common tasks that you might want to do in Flutter. So this is just a sample of what's there, but you can see that there's a lot of great content that you'll use in almost any app, such as animations, design elements, and networking. And then the next thing to talk about, plugins, are essentially just a fancy word for libraries or modules, and are one of my favorite things about Flutter. Because the development community is so active and passionate about the platform, they've created thousands of open source plugins that you can use in your apps to easily accomplish tasks without having to reinvent the wheel. So you can find most of these plugins by using pub.dev, which is a site created by Google for searching through plugins and finding their documentation and source code. Since you can find the specifics for implementation on each of these plugins though through their site, I'll just introduce them now for this talk so that you're aware of what they are when you're looking for them. So while there's a ton of great third-party plugins out there, I figured I would start with Google Maps, since it's one of my favorites and my go-to when I need to display location information for my users. This plugin will display a map for your users and allow you to customize it with styles, pins, and drawings. Next up is FlareFlutter. So FlareFlutter is a third-party plugin that I thought was just kind of too cool to not include in this talk. This plugin is great when you want to animate icons, buttons, and other items in your app to add some extra kick to your UI, which is always great when you're trying to sell an idea to someone or just show it off for hackathon judges. It's worth noting that you can do some of this manually using native widgets like Animation Builder or Transform, but it's just not nearly as easy. And then while we've talked a lot about rapid prototyping for strictly UI apps, it's becoming more and more common that people need to make prototypes that consist of an app with a hardware device. So given this, the next plugin that I wanted to introduce is called FlutterBlue, which is a plugin that helps you communicate with Bluetooth devices using a Flutter app. This handles finding, connecting, and communicating with Bluetooth LE devices with only a few lines of code, and is invaluable for anyone that's working on IoT projects. And then since there's hundreds of other plugins out there, I can't even begin to make a dent describing all of them in a series of talks, let alone a single talk. But I would really recommend that you search for anything that you're trying to do in Flutter first, just see if it's already out there as a plugin that someone else has already made, just to save you a lot of time and to help you actually make things really quickly. So for the next part of this talk, we'll learn a little bit about Firebase and how it's used with Flutter through Google's open source plugin, Flutterfire, which you can find on GitHub. So first, let's just go over the official pitch for Firebase. Firebase is an application development platform with a mission to help app developers succeed by using Firebase products. Firebase accomplishes this by taking common problems and developer tasks that occur during your product's lifecycle and making them easier to solve, be it by providing more information about your apps and their performance, or providing tools to handle complex problems like security and network connectivity when storing data. So Firebase is actually divided into three main categories of tools, each with specific goals: helping you build better apps by making complex coding processes easier, improving app quality by helping you catch issues early and fixing them quickly, and helping you grow your app by understanding how other people are using it and engaging with them in a meaningful way. So as you can see here, there's almost 20 different products within Firebase. And while that may seem like a lot, today we're only going to look at a subset of all the Firebase features that are most relevant to rapid prototyping. So again, the goal here is not to overwhelm you, but just rather to let you know what's available when you need it. So the first feature that I want to go over is authentication. While it's not the most flashy feature, there's always that one hackathon judge who's going to ask you about security, so you might as well just toss it in since it's easy enough to use. Firebase authentication will allow your users to log into your app using a username and password, a phone number, a third-party identity provider like Google or Facebook, or a few other options. So to keep things short, I'm going to just go over how to use Google Sign-In. So from my own experience, this is actually one of the easiest of the third-party authentication methods to use, but that's because we also have a Google Sign-In plugin to help streamline this process. If anyone is interested in a very detailed look into Firebase authentication, though, I actually have a series of blog posts out on Medium that I've recently released and I'm still working on. So you can find a lot more information and detail on how to use authentication within Flutter. So a major part of the setup process for Firebase authentication actually occurs in the Firebase console. So aside from linking your app to Firebase, you'll need to enable each type of Firebase authentication that you will want to use from the Firebase auth section in the Firebase console. After project setup and enabling auth, you can go back to the code for your app. So the first thing you'll need to do in your code is instantiate the Google Sign-In object, which then calls the sign-in method on it. If the user's device is able to use Google Sign-In, then it'll be prompted with a sign-in dialog similar to this. If the user's on iOS or web, it'll actually open up a new browser window where the user can type in their email and their password, and it'll return the same exact credentials. It's just not going to have the same UI that you would get off of an Android device. And then after the user has selected their account, you'll be able to receive a Google Sign-In account object. So you can use this to call authenticate against Google's identity provider service. And then once the user is authenticated, you can retrieve their auth credentials from the Google Auth provider. And then finally, you can retrieve the Firebase user using the Google Authenticator credentials. Additionally, if the user has already been previously authenticated, then you can actually just call this single current user method off of the Firebase auth instance, and it'll return that user for you. So next, I just want to talk about the two database options that are available in Firebase. The first one, real-time database, uses a simple JSON tree structure to store and access data. This data is stored and synced between users and devices, and its main goal is to provide a back-end data source solution without having to go through the whole tedious process of setting up your own database server, authentication schema, REST endpoint, and everything else that goes along with building a typical database infrastructure. So the first thing you'll need to do to use the Firebase real-time database is create a Firebase database object in your app. You can then create a reference to a specific node in the JSON data, tree data structure. So in this case, that node is just called messages, and it's a child of the root node. You can then create as many references as you like, such as this part of the code that creates a reference to the counter node and then reads the value from it one time before printing it. After you have your reference, you can associate it with the listener in order to take action on any data changes as they happen. And then finally, I just want to introduce a new graphical widget from the FlareFlutter library called Firebase Animated List. This works like a standard list, but it will animate as items are added or removed from it, and it works specifically with Firebase references to listen for data changes without you having to tie everything together manually. If this widget doesn't work for your use case, though, there's also the Firebase list and Firebase sorted list widgets. And then the second option, Cloud Firestore, is a database tool that allows you to group data using a document collection structure for straightforward access. It offers many of the advantages of the real-time database, such as real-time syncing, offline support, and scalability, but also supports basic queries in addition to direct data access. One thing that's important to remember is that Cloud Firestore can be used in conjunction with the real-time database, as each can serve its own unique purpose within your app. So you don't have to pick one over the other for every case inside of your app. You can use one for one thing and one for the other and have them together in your app. We'll skip the code discussion for the next few slides for today because of time, but you can find all of this and other complete samples in the Flutter Fire repo on GitHub. And then while we've talked about database options already, sometimes you need to store and serve user-generated content, such as images or audio files, directly in your mobile app. So you can do this using cloud storage for Firebase. Uploads and downloads handled by the Cloud Storage SDK are resumable, making them more resilient to changes in network connectivity. When a user's connection is disrupted during an upload, the SDK will automatically handle retrying and resuming, which can be critical when dealing with the kind of network conditions often encountered on mobile devices. Downloading content uses a similarly robust system, allowing users to receive their data once a connection is successfully reestablished. Once the user's content is uploaded, it can be shared with other users of your app using the same exact SDK. And since you will likely run into situations where only certain users should be able to see or upload specific content, you can use Firebase's security rule system, along with Firebase authentication, to restrict content according to your app's requirements. Cloud functions for Firebase are single-purpose functions that are executed in a secure, managed environment for your Firebase project. They are powerful tools that let you handle complex logical operations from within Firebase, such as performing operations on your Firebase database, or interacting with various other Google or external services. These are great for handling backend logic for your app without setting up a whole complicated backend. And at the last FireConf, we also released a new product called Extensions, which are pre-made functions that handle common tasks for developers without having to reinvent the wheel. So you can find them in the console to see what can work out for your app, and there's still a lot more that are being released over time. But here you can see we have examples for resizing images as they get sent to Firebase storage, translating text that has been written to the Cloud Firestore, or various things for sending emails out to your users. So today we've covered a lot. If you want to learn more about Flutter or Firebase in depth, then the top few links will give you a ton of information and resources like code labs and videos. So for Flutter, I highly recommend checking out the Flutter Cookbook that we had talked about earlier, and you can find more information about all of these features available in Flutterfire on GitHub. Again, my name is Paul Ruiz, and I'll be posting these slides for this talk up on Twitter under my account that you can find here on this slide. Or you can just reach out to me directly if you want through my work email address at ptruiz@google.com if you have any fairly in-depth questions. Thanks. Let's see. Oh, it looks like we do have a question here. Is Flutter only good for prototyping or could be for intense production environments? So there actually are multiple companies out there that are using this in their as their production. So I know a lot of the Google Assistant apps are using Flutter. I know, let's see, I think it was New York Times is publicly using it. Let me see if I can find the actual list that we have. We have a showcase. So Realtor.com is using it. Tencent out in China is using it. New York Times, Square. There's a few others that are actually using these Flutter for production apps. Cool. And if there's any other questions, great. Cool. All right. If that's it for questions, then I hope everyone has a good evening, and I will hopefully talk to more of you soon.